morning students. Let's see hardness determination of water with the help of EDTA method. So which salts responsible for making hardness in water? So hydroxide, carbonate, bicarbonate, chloride, sulfate, nitrate of calcium, magnesium, iron, manganese and other heavy metal ion when they are present in our water which make water hardness. So depend on these salts, water having two types, temporary hardness and permanent hardness. So when water having hydroxide, carbonate, bicarbonate of these metal ions, then our water having temporary hardness causes. Whereas apart from this, if water contains chloride, sulfate, nitrate of calcium, magnesium, iron and other heavy metal ion, such a water is permanent hardness causing salt water. So this is the basic idea what type of ions or salts are responsible for hardness of water. And total hardness is nothing but addition of temporary hardness plus permanent hardness. So how to determine the hardness present in the water? For that we must know the principle. So the hardness present in the water can be determined by titrating the hard water with disodium salt of EDTA in presence of erythrochrome black tea indicator and buffer solution having pH 10. What type of chemical required? So these are the chemical required. First, for standardization of disodium salt of EDTA, we require initially disodium salt of EDTA. Next, ZnSO4 solution, zinc sulfate solution of capacity 0.01 molar, erythrochrome black tea indicator, which is shortly said as EBT, and buffer solution having pH 10 capacity to maintain the pH of solution. Finally, we require the hard water. So these are the chemicals. Now, let's see the structure. So EDTA is ethylene diamine tetraacetic acid, which is not completely soluble in water. That's why we are using its disodium salt. In that EDTA structure, replace 2 hydrogen of acetic acid with sodium atom. So that is your disodium salt of EDTA. Now, when our water titrate with disodium salt of EDTA, there is a formation of metal EDTA complex which is having hexa bond. So this complex is called as a hexadentate ligand, and such a type of titration is called as complexometric titration. Let's see actual procedure. So for EDTA, for total hardness determination practical, we have 2 steps. First step, standardization of Na to EDTA, and second step, total hardness of water determination. How to standardize it? For that, initially we require burette. Fill the burette with disodium salt of EDTA. At Z0 level, remove the air bubble. Take conical flask. In that, add known amount of ZnSO4 of 0.01 molar. Add few drop of erythrochrome black tea and buffer solution of pH 10. So there is a formation of wine red color complex. Now titrate that wine red color complex with purine solution containing disodium salt of EDTA till color change from wine red to blue. Note the burette reading as a V1. This reading is used to calculate the molarity of disodium salt of EDTA with the help of M1V1 is equal to M2V2 formula. From that, M1 is equal to M2V2 divided by V1 and the unit is molar. This is the first. Now what type of reaction happen? Now in first case, here zinc 2 plus react with EBT. In presence of buffer solution, there is a formation of zinc EBT unstable wine red color complex which is then titrated with disodium salt of EDTA, and that convert it into Zn EDTA which is colorless, and the blue color is due to the EBT indicator. Let's see the second step. We have to find total hardness present in the water. What is the step? We have to repeat the procedure. But in this step, inside the conical flask, take water sample of known amount, add EBT indicator, add buffer solution. So there is a formation of wine red color complex. Now titrate it with disodium salt of EDTA till color change from wine red to blue. The point where wine red changes to blue, note the burette reading reading as XM. This burette reading is used to calculate total hardness, having the formula burette reading X into molarity of EDTA into 10 raised to 5 divided by volume of water. And the unit of total hardness is ppm. Which type of reaction occur at this stage? So as we know that water having calcium 2 plus or Mg2 plus, it react with EBT. When we are adding EBT, few drop of buffer solution, there is a formation of calcium EBT or magnesium EBT bi-red color complex. It is unstable, so titrate it with disodium salt of EDTA which is present in the burette till color change from violet to blue, whereas calcium EDTA or magnesium EDTA having the colorless form. So this is the way by which the total hardness present in the water can be proceed or can be determined. Now here, how we are finding the permanent hardness? So here, in this case, we can again take water sample in a beaker, boil it. So whatever the temporary hardness causing salt present in the water, it gets precipitated out. Filter that water. Whereas the filtrate octane which is used for finding the permanent hardness. How we are finding the permanent hardness? Procedure remains same. But here, instead of the normal water, we are using the filtrate octane after the boiling. Add buffer, add EBT, by red color form, titrate to blue. Note the burette reading as a bi-red. This reading is used for finding the permanent hardness, which is by into molarity of EDTA into 10 raised to 5 divided by volume of water. As we know that total hardness is permanent hardness plus temporary hardness. So from that total and permanent hardness we can find the temporary hardness. Temporary hardness is total hardness minus permanent hardness. We get the temporary hardness. So this is the way by which we can find the hardness present in the water. Thank you everyone.